Now that we have set up the movements, let's take care of the animations. For this tutorial, I'm going to be using this animation pack. You can use any animation that you want. This one is not free, I believe it's $50, but the animations are of great quality. If you have any custom animations, feel free to use them too. I'm going to add the animation pack to my project. Let me move it to my asset folder to keep it organized. I don't need the map that is included, so I'm just going to delete it. I'm just going to move all the mannequins in one folder to keep it organized. Now, first thing, I'm just going to use the mannequin provided by the animation pack, just because I don't want to go and retarget all the animation to my current mannequin. Feel free to retarget all the animation to your custom mannequin if you want. Also, I'm going to use the mannequin without the weapon, as I do want to show you guys how to spawn and equip a weapon or multiple weapons properly on the server. Now let's work on the animations. In the player's characters folder, right click, then go to animations and Blendspace. Select the skeleton of your mannequin that you are using. I'm gonna name it BS for Blendspace player character. Click grade to help things snap into place. Name the horizontal axis to direction, mean value of -180, max value of 180, grid division set to 8, and snap to grid. Name the vertical axis to speed, min to 0, max to 450, grid division to 6, and snap to grid. Then scroll down and set the weight speed to 15. It is the transition speed between the animation that we are going to be adding. Feel free to experiment with different numbers if you want. Now let's start with the idle animation. Drag it on the bottom line at speed 0. So when we are not moving, we want to play the idle animation. Next is the walk animation. Put the backward animation at both extremities at speed 300. You can hold Ctrl and move your mouse on the graph to play the animation. Next is front right walk animation, then right, then backward right animation. Next is front left, then backward left. Now the jog animations. First the forward animation in the middle, then the backward animation at both ends. Then front right, then right, and then backward right animations. Next is front left, left, and then backward left animation. To use the blend space that we just created, we need an animation blueprint to give to our character. Right-click, Animation, Animation Blueprint. I'm going to name it ABP for Animation Blueprint, Player Character. In the animation blueprint, right-click and add a state machine. Name it Locomotion. Now drag from its output and find a slot. The slot will be used to play animation on top of our movement animations, and then connect it to the output pose. Inside Locomotion, let's add a new state from the entry and name it idle, walk, run. Now let's find our blend space and connect it to the output pose. Now our blend space requires some inputs to work properly. To access these properties from our character, we need to make a C++ version of this class that will let us collect all these informations. Let's go to Tool and make a new C++ class. Select all classes and look for AnimInstance. Make it public. I'm going to name it TP AnimInstance and put it in a animation instance folder. Now let's make a public section. We are going to override the native initialize animation function, which is like a begin play function, and the native update animation, which works like a tick function. Now we create a private section to store some properties. Let's create a reference to our base character and set it up to null. Don't forget to forward declare it at the top. Next, we need a reference to the character movement component to extract information from it. Let's make a ground speed variable, and we do have to allow private access to it because it's in the private section, and we do want to access it from the blueprint. Next is a boolean for acceleration that we are going to set to false by default. Then an F rotator to get the aim rotation. Another one for movement rotation, and one last for movement offset yaw. Let's generate these functions. There seems to be an issue here. Let me just close and generate the project files again. The animation folder is not in the public or the private folder. Let's fix that. First, I'm gonna move it to the public folder. Then in my private folder, I'm gonna make a new folder with the same name and move the CPP file to it. Now let's try again and make the definition for these functions. In native initialized, we are going to get the pawn that owns this animation instance. From the pawn, we can cast to get the base character. And from our base character, we can get its movement component. Make sure you include the base character header file. I'm also going to include the movement component header file here. In NativeUpdate, we check if our base character and movement component are valid. Now let's update our B is accelerating variable by getting the acceleration from the movement component and checking if it's greater than 0. Next is the ground speed, but we will require the Kismet.mat library here. From the library, we are going to get the speed by using this function and passing in our velocity like so. Now our aim rotation to know where we are looking at. Next is the direction our character is moving. Then finally, we can calculate the difference between where we are going and where we are looking at, so that we can face one direction and walk into another, like strafing. Let's compile. In the animation blueprint, click on class settings and set the parent class to the C++ class we just created to get access to all the properties. Now we can right click and look for ground speed and connect it. Then get the offset yaw and connect it to direction. Let's go to our player character and set our anim class to ABP player character. Now, if we press play, we should have a proper running animation. You will notice that when we are moving, everything is fine, but if we stop moving and move our camera around, it rotates our character. In my case, this is not the behavior that I want, so let's fix it. Let's go to our character blueprint and uncheck UseControllerRotationYaw. Now, if we move our camera, it doesn't rotate the character anymore. But if we start moving, it doesn't rotate the character also. So what we want is, if we are moving, to set UseControllerRotationYaw to true, and if we are not moving, to set it to false. Let's go to our anim instance. Now if B is accelerating is true, meaning that we are moving, then B UseControllerRotationYaw will also be true, and vice versa. I'm just going to give all the control rotation a default value in the C++ by setting them in the player character. Now let's test this out. Next we will be working on giving a weapon to our character, and then finally making our dedicated server and uploading it to GameLift and test it out.